Hello everyone. I hope you all are doing well. This is Meghna Bhakchandani, student of Government Women Engineering College Ajmer, pursuing BTech from Information Technology. Here is my training presentation on machine learning and data science using Python. Here is my training details. The mode of the training is online. Platform of my training is Go Hub Technology. Start date is 20th May 2021 and end date is 5th July 2021. Duration of my training is 45 days and number of hours is 90. Marks obtained is 100%. Here is my certificate. So let's start. Basics of Python. Python is a general purpose dynamic high level and interpreted programming language. It supports object oriented programming approach to develop applications. Python supports both procedure oriented and object oriented programming, which is one of the key Python features. It also supports multiple inheritances. Python run equally on different platforms like Windows, Linux, Unix, etc. Python code simple, it makes them more readable and understandable. We can use Python to develop web applications. It also provides frameworks such as Django, Pyramid to design and develop web applications. Python downloads with large library that you can use so you don't have to write your own code for every single thing. Python decision making. Decision making statement in programming language decide the direction of the code. In Python, it supports condition from mathematics. In Python, we do decision making by following statement. First is if else statement. If condition passed in if statement is true, statement are executed. If the condition in if statement is false, then it goes into else and execute that statement. If else statement, nested if statement. So here is example of if else statement. Python list. The Python list is a general data structure widely used in Python programs. They are found in other languages, often referred to as dynamic arrays. They are both mutable and a sequence data type that allows them to be indexed and sliced. The list can contain different type of objects including other list object. List methods and supported operators are append, extend, index, insert, pop, remove, reverse, count, sort, clear, replication, element deletion, and copying. List slicing. This means that slice operator will do slicing which start from indexes start will go up to stop in step of steps. Default value of start index is first element of list. Stop index is last element of list and step is 1. If any one of the three value is not given, then it will consider default value of that index. Python tuple. Tuple is a sequence of Python object like list with immutable features. We cannot add or remove an item in tuple and tuple is closed by parenthesis. So here is the example of the Python tuple. Python dictionaries. Dictionaries in Python are unordered collection of items. A dictionary is closed by curly brackets. Dictionary hold pair of key and value. Key and value separated by colon, whereas each item in dictionary is separated by comma. Some functions and methods for dictionary. First is CMP. Compares elements of both dictionary. LEN gives the total length of the dictionary. STR produces a printable string representation of a dictionary. Type returns the type of the passed variable. Dict.clear removes all items of dictionary. Dict.copy returns a shallow copy of dictionary. Dict.get for key returns value or default if key not in dictionary. So let's move to the next slide. Class in Python. A class in Python is a blueprint or template from which specific objects are created. To understand the concept of class and object, we think of class as a sketch of a house. It contains all the details about the floors, doors, windows, etc. Based on these description, we build the house. Here we can say that house is a object and house blueprint is class. So basically a class is a design for an object. Class variable. Class variable is a variable that is shared by all the different object instances of a class. Instance object variables. Instance object variable are variables which are unique to each instance. It is defined inside a method and belongs only to the current instance of a class. Basically, an object is everything we can see around. For example, a person is an object of human class. Methods. Methods are also called as functions which are defined in a class and describe the behavior of an object. Python constructor. A constructor is a class function that begins with double underscore. Constructor automatically called on class object creation. When we create a class without a constructor, Python automatically creates a default constructor that doesn't do anything. Constructor can be of two types: parameterized constructor and non parameterized constructor. So, the next topic is web scraping. Extracting the data, basically HTML files, of any website is called web scraping. This saves lot of time because we get lot of data in structured form. We can extract the data of any website in two ways: by using API of a website. Some website like Twitter, Facebook, YouTube have an API. By using API of a website, we can extract data of website. But all websites do not have their API. In this situation, we extract data of website by accessing their HTML page. It is called web scraping. Here's a list of features of Python which makes it is more suitable for web scraping. First is ease of use. Python is simple to code. You do not have to add semicolons or curly braces anywhere. This makes it less messy and easy to use. Large collection of libraries. Python has huge collection of libraries such as NumPy, Matplotlib, Pandas, etc., which provide methods and services for various purposes. Hence, it is suitable for web scraping and for further manipulation of extracted data. Third point is dynamically typed. In Python, you don't have to define data types for variables. You can directly use the variables wherever required. This saves time and makes your job faster. Fourth one is easily understandable syntax. Python syntax is easily understandable mainly because reading a Python code is very similar to reading a statement in English. It is expressive and easily readable. And the indentation used in Python also helps the user to differentiate between different scope blocks in the code. So here is the introduction of the machine learning. Machine learning, or we can say that ML, is a type of artificial intelligence, which is AI, that allows software application to become more accurate at predicting outcomes without being explicitly programmed to do so. Machine learning algorithms use historical data as input to predict new output values. Machine learning is important because it gives enterprises a view of trends in customer behavior and business operational pattern, as well as support the development of new products. There are four basic approaches. First is supervised learning, second unsupervised learning, third semi supervised learning, fourth is reinforcement learning. First is supervised learning. In this type of machine learning, data scientists supply algorithm will label training data and define the variable they want the algorithm to access for correlations. Second is unsupervised learning. This type of machine learning involves algorithms that train on unlabeled data. The algorithm scans through data sets looking for any meaningful connection. Semi supervised learning. This approach to machine learning involves a mix of the two preceding types. Data scientists may feed an algorithm mostly labeled training data, but the model is free to explore the data on its own and develop its own understanding of the data set. Reinforcement learning. Data scientists typically use reinforcement learning to teach a machine to complete a multi-step process for which there are clearly defined rules. Data scientists program an algorithm to complete a task and give it positive or negative cues as it works out how to complete a task. Python NumPy, introducing object for multi-dimensional arrays and matrices as well as functions that allow to easily perform advanced mathematical and statistical operations on those objects. NumPy provides vectorization of mathematical operation on arrays and matrices, which significantly improves the performance. Many other Python libraries are built on NumPy. Arrays. A NumPy array is a grid of values, all the same type, and is indexed by a tuple of non-negative integers. The number of dimension is the rank of the array. The shape of an array is a tuple of integer giving the size of the array along each dimension. So here is an example of the NumPy. Let's move to the next slide. And this one is Python pandas. Pandas use mostly for data analysis, provides tool for data manipulation, reshaping, merging, sorting, slicing, aggregation, etc. Allows handling missing data. Pandas is a Python package that deals mostly with series, data frame, panel. Popular method of pandas are dtype, data type of values in series, empty, true if series is empty, size, number of elements, values, returns values as nd array, head, first n elements, tail, first n elements. Supervised machine learning. Supervised machine learning requires the data scientist to train the algorithm with both labeled inputs and desired output. Supervised learning algorithms are good for the following tasks. First is binary classification, dividing data into two categories. Second is multi-class classification, choosing between more than two types of answers. Third is regression modeling, predicting continuous values. Fourth is ensembling, combining the prediction of multiple machine learning models to produce an accurate prediction. There are two types of supervised machine learning. First is regression, second is classification. Regression. It is a type of supervised machine learning. It is used to predict the relationship between dependent variable and given independent variable. Different types of regression are linear regression, logistic regression, polynomial regression, stepwise regression, ridge regression, lasso regression, and elastic net regression. Let's move to the next slide. So the topic is unsupervised machine learning. Unsupervised machine learning can be thought as self-learning, where you do not need to supervise the model, where model have to work on its own to discover information. Unsupervised learning mainly deals with the unlabeled data. They shift through unlabeled data to look for patterns that can be used to group data points into subset. There are two types of unsupervised machine learning. First is clustering, second is association. First is clustering. The method of identifying similar groups of data in a data set is called clustering. It basically allows you to automatically split the data into groups according to similarities. In simple terms, grouping data based on similarities. Actually, we used unlabeled data in clustering. Unlike supervised machine learning, clustering is a part of unsupervised machine learning. As we know, we do not have to label data here, means we do not have any prior information about data. So, what we do here, we divide data into groups based on some similarities. Naive Bayes classifier. It is supervised learning algorithm used for classification on Bayes theorem. NBC is just an algorithm, but a collection of many algorithms that works on same concept, the Bayes theorem. Industrial use of naive-Bayes classifier is news categorization, spam filtering, object and face recognition, medical diagnosis, weather predictions. Bayes theorem. NBS works only on the Bayes theorem. Let's see what the Bayes theorem is. So here's the Bayes theorem, which means S is hypothesis, E is event, evidence. Bayes theorem works on conditional probability. We have been given that if the event has happened or the event is true, then we have to calculate the probability of hypothesis on this event. means the chances of happening h when the event is happened. Let's move to the next slide. So the new algorithm is k nearest neighbor algorithm. KNN is simple supervised learning algorithm used for both regression and classification problem. KNN is basically store all available cases and classify new cases based on similarities with stored cases. What happens in KNN? We train the model, and after that, we want to test our model. Means we want to classify a new data. For that, we will check some classes around it and assign the most common class to test data. K is number of nearest neighbors. K is equals to 1 means the testing data given the same level as the closest example in training set. And K is equals to 4 means the labels of the four closest classes are checked and most common class is assigned to the testing data. So how does KNN work? Let's understand it with the above given diagram. In this diagram, we have two classes, one blue class, one red class. Now we have a new green point. We have to find out whether this point is in class red or blue. For this, we will define the value of k. At k is equals to 1, we will see the distance from the green point to the nearest point and selected the point with lowest distance and classify the green point in that class. Here it red. At k is equals to 5, we will calculate the distance from the green point to the nearest point and select the 5 points with the lowest distance and classify the green point to the most common class. That is red here. How to choose the value of k? The value of k is not defined, it depends on the cases. So the topic is support vector machine. Before support vector machine, we need to know what is machine learning is. Machine learning is a part of artificial intelligence. What we do is feeds both the output and input data to the machine. This is called training our model. In a way, the learning process of model is called training the model and predict a possible outcome using the algorithms. You can understand more well from the following diagram. Next slide. Support vector machine. Support vector machine is a supervised learning algorithm for classification problem. What happened in this algorithm? We separate the two classes with hyperplane. In first diagram, we see that we have separated two classes by hyperplane. But as you can see here, we made many hyperplanes. So the question is why we did this and hyperplane is correct. Now we look at the diagram 2. Here is what we have done. We have drawn two lines touching the last element of both the classes. The distance between two lines is called margin. And the last element of the class, by touching them, we have created lines are called support vector. So now, how will we decide which of our hyperplane will be among so many hyperplanes? Because all the hyperplanes are separating classes. So here we introduce a new term, and that is the maximal margin hyperplane. So this means that our optimal hyperplane will be the one who has maximum margin. So here is the completion of the presentation. Thank you. Thank you for being a patient listener. Thank you so much.